Go to the next presenter. The next presenter is Vasilis. Hey, he's already here. So he will present internet-wide view of large-scale IP sharing on measurement interface and service provision. Vasilis is a senior research engineer at Cloudflare, working in network measurement, telemetry, and security of critical internet infrastructure. He was an assistant professor at Lancaster University, where he led the network security research. He has played a key role in multiple mission-critical research projects funded by the UK National Cybersecurity Center and the US Department of Homeland Security. Vasilis, the stage is yours.
De Seguridad Nacional. Muchísimas gracias. Hola a todos. Este es un trabajo de colaboración con un grupo, Neil Wood y Antoine Cordelet y Nick Wood y Stefan Rubin y Marwan Fayed. Hoy vamos a analizar cómo compartir la IP a gran escala, pero primero vamos a explicar por qué querríamos hacerlo.
IP-based filtering is one of the most popular security techniques, and it can be done either with blocklists, where we drop completely traffic from IPs that we have found to be participating in past attacks, or by rate limiting the number of requests an IP can send. Or sometimes something a bit more sophisticated is by trying to detect anomalous patterns of requests, right? Deviations from what someone may consider a normal IP behavior. One problem with this widespread technique is that it may incur collateral damage. And what I mean by that is that every client has an IP, but an IP can have multiple clients behind it, sometimes hundreds or even thousands. And I particularly talk about two types of shared IPs. Carrier-Grade NATs, which are used by ISPs in order to accommodate multiple users behind the same IP, so they preserve the scarce IPv4 address space. And VPNs or proxies, which essentially are options by the user who wants increased privacy or sometimes performance. So one key distinction between carrier-grade NAT IPs and VPN and proxies is that CG-NAT is not a choice of the user, right? They may not even know they're using CG-NAT. Actually, I'm pretty sure most users have no idea what is CG-NAT, which means that if one of the users behind a CG-NAT gateway misbehaves, it would be unfair to punish every user behind the same gateway, right? So this is something that is very undesirable. On the other hand, we've observed purposefully malicious abuse of VPN IPs over time. Unfortunately, if you do a quick Google search, you will see that a lot of CG-NAT users are frustrated often because they are being blocked or they are being throttled and have no idea why that happens. And in the past, the UK regulator for communications, Ofcom, did a report on the implications of CG-NAT. And one of the things they pointed out is that, indeed, this is a problem for CG-NAT users. They are being blocked, although they have done nothing, right? And users sometimes blame ISPs because they use CG-NAT. Other times blame the security providers, like Cloudflare or Google. So we need to do something about it. What's even worse, if that was not already bad enough, is that there is a socioeconomic bias on which users are being affected. In this map, we see the number of available IPs per user. And you see that developing countries in particular have much fewer IPs per user. So they have to rely even more on CG-NAT, meaning that these security techniques affect developing economies more. So the goal of the work we're doing is that we are trying to detect which IPs belong to CG-NATs and VPNs and which IPs are not shared, so that we calibrate IP filtering, and we try like that to minimize the implications of this filtering to users of shared IPs. How we try to do that? The main idea is quite simple. Since we're a large CDN, we observe billions of HTTP requests from billions of IPs per day. So we try to extract some features from these HTTP requests per IP and build what we call a supervised machine learning classifier, right? So we have some training data, we feed it the features, we create a model, and then we use this model to predict the type of IPs we observe sending requests. And like that, we can distinguish CG-NAT IPs from VPNs or from non-large-scale shared IPs. This is pretty standard in machine learning, right? That's very basic. What is important here is what features we select so that they are informative enough to distinguish these different types of IPs. And importantly, how do we find a training data set that will be labeled with a type of IPs, right? How do we know which IPs are CG-NAT or VPN or nothing of these types so that we train this classifier? Unfortunately, there is no readily available data set on CG-NAT IPs in particular. There are some lists with VPNs, nothing though definitive on CG-NATs and non-CG-NAT IPs. So we try to employ a combination of techniques to measure those things. First, we run distributed traceroutes from RIPE Atlas. And in the traceroute path, we try to detect whether there are private IPs or IPs in the shared address space before going to public address space. So in this traceroute, you hear the highlighted hops. We go from private address space to shared address space and then to public IPs, which is a strong indication that CG-NAT is deployed in this case. Another way of collecting CG-NAT IPs for our training data set is by parsing WHOIS records, parsing the description field, which sometimes indicates the use of the IP. You can see here, it's explicitly mentioning that this resource is used for CG-NAT. And other times, there are hints encoded in the pointer DNS records of IPs. So we do an internet-wide DNS scan. We collect those PTR records, and we try to parse the strings to extract those hints. Like that, we constructed a relatively extensive data set of, let's say, ground truth IPs. We have hundreds of thousands of IPs in many thousands of ASs all over the world. Now, I acknowledge that all of these sources of information on their own are imperfect. The actual technique is much more nuanced, but I have to skip some of the details. We are going to publish a more detailed report on exactly how we construct it, and I'm happy to discuss with you later. But having collected these IPs, the next question is, how do we select the features that would be informative? So we go to our HTTP logs, and we try to find features that would signal a large user population behind an IP. And these features can be volume of requests, but also diversity of clients. For instance, diversity of user agents per IP, which encode operating system, browser, device type, and so on. It can be diversity of TLS fingerprints per IP. An important feature we have found to be RTT variability, because users behind CG-NAT and VPNs are spread across larger geographical areas. And we aggregate those features for the duration of a day, and we feed them to our classifier. So we use a simple classifier, XGBoost, which performs well for imbalanced data. And it actually performs very well. We found it to be 98% accurate, 97% F1 score. The important bit here is that we can distinguish well VPNs from CG-NATs, because as I said earlier, it's very undesirable to block CG-NAT IPs, but for VPNs, it's sometimes desirable. And what helped us to do that is that we aggregate the features I mentioned before, not just per IP, but also per /24 prefix. In these distributions here, you see the distribution of, let's say, distinct user agents in plot A per IP, in plot B per covering /24 prefix. Blue line is non-cert IPs, non-multi-user IPs. Red is CG-NAT IPs. Green and yellow are VPNs and proxies. And you will see that when we look at the per IP distribution in plot A, the blue line stands out from the rest. So per IP distributions can help us distinguish non-cert IPs from cert IPs. Now, if we go to plot B and we see the distribution of user agents per /24, suddenly the CG-NAT IPs in red are apart from the VPN and proxy IPs. And if you think about it, it makes sense because usually CG-NATs are allocated block of IPs, while VPNs and proxies may have separate IPs in separate prefixes. Now, that's why when we plot the feature importance, the /24 aggregation of the features is the more informative. So we applied this technique on the Cloudflare data, and we tried to analyze the blocking and throttling done by our clients. What we found is that, first, CG-NAT IPs generate about 16 times more requests compared to the non-cert IPs. And that may make them appear suspicious to someone. And indeed, when we see how often those IPs are throttled, like those CAPTCHA things you often get, they are throttled 3 times more often than non-cert IPs, although they have the same bot score. The bot score is a score that we assign to each IP based on whether we believe it's a bot or not. And despite they don't have different bot score, they are blocked much more often, right? And we see that the global distribution is indeed skewed. The highest raw numbers are in the US, Brazil, and India. But if we see the proportion of IPs, then you can see on the lower map that many countries in Africa stand out and Southeast Asia, right? So indeed, to have equitable security measures, we need to take this IP sharing into account. So to conclude, it seems that it is possible to identify these cert IPs in the wild. It is important to do that in order to minimize collateral damage. Diversity of characteristics, and not just volume, is a key, as well as the aggregation per IP and per /24 prefix. I want to draw your attention to a recent IETF draft proposal on prefix lengths. This proposal defines some RPSL tags that would allow ISPs to self-publish which of their IPs are CG-NAT, and then like that it will allow us, like security providers and content providers, to treat those IPs more lightly, right? Not block them, not throttle them as much, and so on. And finally, I want to ask you, if you are an ISP and if you use CG-NAT, to share this information privately, of course, with us so that we can improve our training, we can improve our filtering, and I think this is both for the benefit of our users and also the benefit of ISP users. Thank you very much. I am ready to take questions if you have any. Thank you.
Thank you, Vasilis.
Thanks.
Do we have any questions for Vasilis? No? I'll ask you a question then. There may be CG-NAT IPs with a small number of subscribers. How can you infer those?
Sí, hay despliegue de CG-NAT que no tienen muchos suscriptores. Creo que lo que resulta importante es detectar los CG-NATs que tienen muchos suscriptores, porque estos son los que se ven afectados por el tipo de filtrado equivocado y por el bloqueo equivocado. Y de esa manera lo llamamos de gran escala. Bueno, muchas gracias.